Okay, thanks for everyone to come here so early in the morning, and I always enjoyed to give the first talk on in not just the day, in the whole conference. So after that, I can feel relaxed to hear other talks. So today, I'm going to talk about the online traffic speed forecasting. And actually, I just, in the flight I came here, and I saw a movie, it's called a documentary called The Nomar, My Perfect Storm. So there's a famous quote. He said that the fantastic cuisine is about time and place. So when we talk about traffic speed forecasting, it's also about time and place. Given the time, information, and place, that we can try to give the best prediction as possible. And here we just focus on the traffic speed forecasting. And also we consider the data that with multiple periodicity and some other complex patterns. And here we are from National Taiwan University of Science and Technology, and also my colleague usually here, and we work on the same research. Okay, so here is the outline that we try to give you some introduction about the problem and also the model, and right after that we talk about the data and the evaluation. Okay, so the introduction. So actually in the last few years that we focus on the IoT analytics. So given several different applications, and we include, of course, including the transportation on the left. So we try to give build a common framework that we call the continuous sensing and monitoring, so that basically it's other than the traditional machine learning, and we instead of like just build one model and then use the model for quite a long time, and we need a series of models that the model can be as good as possible. Then the model will be used when we are given a continuous data for analysis. Okay, so given that framework, and we need to continuously collect data and do some preprocessing and online data analytics, and sometimes we really need to do it very fast, and so that also that the data size is quite a lot. And also we need to take care that the data usually will have a spatial and temporal relationship. Okay, so just some naive way that we can think about that the data will be like collecting in a single sensor for a long time. Okay, or we take several sensors but at the same time, or we take both. Okay, so given that we know that sometimes we are focusing on the spatial domain or temporal domain, or both of them. Okay, so what about traffic forecasting? And the road traffic forecasting is, of course, is very important because we can use that to plan the trip. And also, sometimes we know that maybe we need to depart at different time. Sometimes maybe we choose to take the public transportation just based on that if we know the result of traffic forecasting. Okay, so there are several factors to decide the road traffic, for us to know more information about road traffic. So basically we can focus on the time and the location, and also sometimes we need to know the weather report, etc. Right? Sometimes there'll be road construction. Okay, so we need to take that, keep that in mind so that we know where we should take the road to drive. Okay, and also there'll be some recent research that we focus on that if you are experienced driver or you are a driver with different patterns, okay, aggressive driver or not, then maybe you have different, maybe you can expect different traffic, right? Okay, so from a data-oriented approach that we talk about that given a lot of traffic data, road traffic data, and we consider the long-term factors such as the periodic behavior. That will be one of the main focus in this research. And also we talk about the shortened factor. That will be very important when we have accidents on the road. So we need to take that into account to have better prediction. And also we need to take into account the spatial relationship and also some relationship between different features such as the speed flow and occupancy that are well-known factors in this research, in this community. So let's take into let's take a look at the figure on the right-hand side. Actually, that's the speed information collected for 7 days, 1 week. Okay, so you can see that we do have several speed drop in the evening. Okay, so which means that we do have the similar patterns across different weekdays. Okay, usually they'll be only for weekdays, not in the weekend, because usually we don't need to work during the weekend. Okay, so there'll be something that we call the, periodic behavior. So that we call the daily periodic behavior and also the weekly periodic behavior. So we try to talk about that in a more general framework. Okay, so there'll be other things. Okay, there'll be as we mentioned, there'll be long-term patterns. That means the periodic patterns, and also there'll be some short-term patterns, such as that in the middle that you see there's unexpected patterns. Okay, not the same from other days. Okay, so that's thing that must be considered in the forecasting. And also, as you can see, that there'll be the green one and the red one that belongs to different occupancy and flow. Okay, they have some similarity, some correlation, so we can take that into account in our prediction. So here is also the pattern across different moments. As you can see that between Wednesday and Thursday, there'll be something similar, but not similar to the Saturday pattern. Okay, so there'll be some similarity between, let's say, if we collect data in different sensors. As you can see that in different post mile, and we do see some similarities here. Okay, so here is the one of the most important slides that I want to share with you. So given the traffic data and what we can try to understand is that the traffic data will have a temporal information, temporal relationship that we need to take it seriously, and also spatial information and also some feature correlation. So down to on the left-hand side, the temporal information, we have the long-term and short-term patterns that we need to take into account. And also for the long-term patterns that we can talk about, sometimes we just have the single periodic behavior. Sometimes we have a multiple periodic behavior to consider. Okay, so here's the focus problem. So given a huge set of historical data about road traffic, and we want to predict what the traffic is going to happen in the next few moments. And here we just, the method that we use is a Gaussian process. Okay, so basically it's an online prediction. As you can see that given the result of the last few moments, we want to predict the result in the next few moments. Okay, so the issue is that, okay, we do have a lot of periodic patterns and also unexpected patterns, and also some other things to consider that we just mentioned, how to combine them together in such a integrated model. So that's the issue we want to focus. Okay, so what's the method? So basically the general traffic data is described here. The X will include the core data, means like flow, occupancy, etc. Right? Sometimes you can also include the weather information, and also for each of the traffic data must be associated with time and the place. Okay, the time means here we have a time index, and place means the sensor information. Okay, so usually in this study that we analyze the traffic along a highway in San Diego. Actually is quite close, not so close. Okay, anyway, San Diego highway. Okay, and given that data, because it's coming as like a time series in different sensors, right? And we do some aggregation. That's the very naive one that we just compute the average after a certain period of time. Then we can try for several minutes or maybe up to 1 hour. Okay, so so that's about if we talk about the periodic pattern, that's about the long-term behavior, right? We also talk about the short-term behavior, means like in the last few moments we want to collect more data in a higher sampling rate. So combined, that's what we call the shortened data. The shortened data is on the orange one on the right. Here will be the shortened data. Here will be long-term data we collected after once per maybe per hour or per few minutes. Okay, so combine them together, then we have then that will be the input for our model. Okay, so that's the online prediction framework. So from the left-hand side, then we have the data, and data will come in, and with some aggregation, some preprocessing, and then that will put in the data set, and that combined with the short-term data, and all together, then we build a model. The model, just like I said, there will be the Gaussian process. Okay, so the time here, it will be something important to focus. Here, the time will be the absolute time index, right? But given that information, we also consider the time in a day and also the time in a week, etc., right? So if we consider the daily periodic behavior and also the weekly periodic behavior, okay? So you can go like several periodicity, like TP1, TP2, etc., okay? So that, like, for instance, here will be the time in a day, a time in a week, etc., right? So you also need to, of course, we need to make it discretize. Okay, so in the end, that the time here, there will be a lot of time information. Okay, we consider in the Gaussian process. Okay, so that we call the multi-periodic model here on the left-hand side, combined with different periodic behavior together, we form a model. Of course, on the right-hand side, we can also, in a naive way, that we can try to simply combine several periodic, a single periodic model together. Then we can have an integrated model. But later, you're going to see that's not as good to the result from the left-hand side. Okay, so here is the Gaussian process. Basically, we have a few data points, okay? So that's the thing that we know. And something in the middle that we want to do interpolation. So the x here will be the input, the y will be the output. Here the x will be just the x I mentioned, several information including the time and the location. Okay, so given that the Gaussian process will help us for forecasting. And I don't want to talk too much about the detail about the math. So here, if we focus on a Gaussian process, we just need to focus on the mean function and the covariance function. That will be right here, mean function and covariance function. The covariance function and so-called kernel function here will be usually, that's quite one of the well-known form that people use. So we need to focus on between two data and how to link these two data together using the kernel function. Basically, just intuitive way is to describe the relationship between two data. Two data means two data collected maybe in different time and different location. Okay, so in the end, we want to do the prediction. So that will be done by this formulation. So x and y will be the historical data, and x will be the new information, maybe like the time and the location, and we want to predict the traffic speed. Okay, so we need to make sure that here we understand that the computation could be painful because here we need to compute the matrix inverse, right? Usually it won't be allowed. Okay, when we have tons of data to analyze. Okay, so the time complexity, we know that for Gaussian process, usually it won't be very efficient. So that's why we need to do some data aggregation to make it as fast as possible. Okay, so some parameter tuning for Gaussian process regression here is that we call is proposed by others. We call automatic relevant determination. So given some historical data, we try to fit the data given a known form of the kernel function. We try to fit that as much as possible. Okay. Then after that, we use the fixed parameter for forecasting. Okay. So here is the data set. It's collected from our RDE. People may familiar with this data. It's like a collection of data, a lot of data. Okay, so a lot of very good informative data that we can collect, especially recently. So here is the data that almost like more than 5 years ago. It's about the San Diego highway data. Okay, so yeah, so that's the highway. Actually, we just focus on 5 sensors here to make the prediction. Okay, and we try to compute the average to get the result. Okay, so here will be the experiment. So we just focus on several different models that I just mentioned that covering the temporal information, spatial information, and also for the temporal information, we cover the long-term and short-term model. Okay, and for the long-term model, we focusing on several different periodicities. Okay, so here is one of the results. If we focus on just single periodicity model, so as we can see that here the x-axis will be different days. Okay, so different days, like we use the training for like 1 day, 2 days, etc. Right? So after, as you can see that after we collect maybe 7 days, the things starts to get stabilized in some sense, right? As you can see that because after 7 days, we collect the data similar to what we are doing, in the current time, right? So that's if we talk about a single periodic model. Here, I forgot to say that the model is we consider the daily periodic patterns, okay? So we don't know about the weekly patterns, okay? We don't know that. So meaning that we only transform the time index to be time in a day, okay? So then we get this model. So we can also consider another single periodic model that covering the weekly patterns, okay? As you can see, weekly patterns will be relatively stabilized because this week and the next week could be quite similar, right? Quite similar, at least more similar than this day and the day before today, right? Okay, the yesterday Okay, so here is the comparison between on the left-hand side will be the daily model, on the right-hand side will be weekly model. As you can see, the weekly model works better than the daily model, as you can imagine, right? Because the daily model is not as accurate because we do have a weekday and weekends, right? That's not considered in the daily model, but weekly model we do have that. Okay, but just like you can imagine that for weekly model we need to collect more data to get the things right. And also we can focus on the table on the left-hand side. So we compare between different single periodic behavior, okay? So, and also we then combine the multi-periodicity model that works the best, okay, as you can imagine, okay? So, and also we combine with the short-term data, just like Before now, we just focus on the long-term data, but here we focus on the short. We also added the short-term data. As you can see, that the result is much, much better because the short-term data is quite important, as you can imagine. And in the end, we have the multi-periodicity model works better than the single periodic model, as you can imagine. And also adding short-term data is quite recommended. Okay, so in the end, just maybe we can focus on this part. After adding all the related information, we can get the prediction as good as 1.4 mile per hour. Okay, the error. Okay, I think that would be good enough for the real application. Okay, also the time will be limited. So just to share with you that we also considered to collect more, and up to now we just focus on just one sensor. But if we focus on more sensors, more nearby sensors, the result will be even better, almost close to the 1 mile per hour error here. And also we focus on the to combine the several features, okay, including the flow and occupancy, and we can get a better result here because the flow and occupancy, as you can see that occupancy when it's high enough, then the row start to get packed, okay, then it will be start to have the traffic, I mean the rush hour, things like that. Okay, the conclusion, actually one of the review comments for our work is that we don't have the baseline comparison. But here, actually, we try to propose some kind of, we believe that there will be one of the meaningful baseline model for other people to compare with. Okay, actually, up to now, we have, yeah, I forgot to say one thing. The prediction is actually for the next 30 minutes. It's like a half hour from now. Okay, so given that, if we can predict for the next 30 minutes and the result is at the most 1 to 2 miles per hour, I think that would be quite, and we are satisfied with the result. Okay, and also the model is an online system. And also we take into account the scalability because we do have the data aggregation to take into account the yearly data that we can process that in real time. Okay, some other details I already mentioned, so I'm going to skip that. Thank you.